Question 5.77. Three resistors are connected to a power supply with V equals 110 volt as shown in the figure. In part A, we need to find potential drop across R3. Then in part B, we need to find current in R1. In part C, we need to find the rate at which thermal energy is dissipated from R2. So here we have a combined series and parallel circuit, and we need to solve part A to C of the question. And before we start solving them, let us first find what is the equivalent resistance of the circuit and the total current flowing through it. So I will start with resistor R3, which is the farthest from the battery. R3 is immediately connected to R2. So we will combine them together to form one resistor. These two resistors are connected in parallel. So we will find their equivalent resistance as R23 equals 1 over R2 plus 1 over R3 raised to negative 1, which will be equal to 1 over R2 is 3 ohms plus R3 is 6 ohms raised to negative 1. So that gives you R23 to be equal to 2 ohms. After we find R23, we will reconstruct our circuit. So let's redraw it here. I keep the battery as it is, resistor R1 as it is. R23 will combine together to form one resistor, which we will write as R23. Now let's find equivalent resistance for the final circuit. Resistor R1 and R23 are connected in series. So I can get R equivalent to be equal to R1 plus R23, which will be equal to R1 is 2 ohm, R23 is also 2 ohm. That gives you the combined resistance of the circuit to be equal to 4 ohm. This is my R equivalent. Once we find R equivalent, we can find the total current through the circuit. Total current I will be potential drop across the battery over R equivalent. That will be equal to 110 volt over 4. That gives me the total current to be 27.5 ampere. Now, if you look at the final equivalent circuit, resistor R1 and R23 are connected in series with the battery. The total current starts from the battery and flows through this circuit. And we know in a series circuit, current through each component of the circuit remains the same. So whatever current was generated at the battery, the same current is flowing through R1 and the same current is flowing through R23. So in part B, where we have to find current through resistor R1, this current is nothing but my total current I, and the value of I we found to be 27.5 ampere. So I can write this to be same as the current through R1, which I will call I1. Then let's discuss part A, where we want to find potential drop across R3. If you need to find potential drop across R3, you need to know the current flowing through R3. And if we look at our main circuit, resistor R2 and R3 are connected in parallel, so they will both have the same potential difference. So if I can find potential difference of the combined resistance R23, it will be the same as potential difference across R2 and potential difference across R3. So let's find potential difference across the combined resistor R23. R23 has a current I flowing through it, as you can see here in the equivalent circuit. So we can find potential drop across R23 as, I will write this as V23. It will be the current times the resistance. Total current is 27.5 ampere. And the resistance R23 we found here as 2 ohms, which is the combined resistance of resistor 2 and 3. So I multiply this with 2. That gives you potential drop across resistor 2 and 3 to be equal to 55 volt. Now this is the potential drop across R23. and R23 is the equivalent resistance of two parallel resistors. And we know in a parallel circuit, potential drop remains the same. So whatever potential drop I got here for R23, it will be the same potential for R3 and R2. So I can write this to be equal to potential drop across resistor 3, which is V3. So we will write here answer for potential drop across R3 to be 55 volt. Next in part C, they want us to find the rate at which thermal energy is dissipated from R2. Rate at which energy is dissipated is nothing but power. So I need to find how much power is dissipated across resistor R2. I already know the potential drop across R2, which is the same as potential drop across R3, which is V3. And V3 we found to be equal to 55 volt, which will be also equal to V2. So I can find the power dissipated at R2 by using the rule power P equals V squared over R. Since we are finding this across R2, I will write this as V2 squared over R2. V2 here is 55, so 55 squared. R2 is 3. And when you solve this, you get the power dissipated to be equal to 1008.3 watt, which you can also write as 1.008 kilowatt.